Hello, and welcome back. This video is about managing save slots in C++. And a special thanks to all my supporters. Thank you for helping me help others. As this is a C++ video, I'm going to start by creating a few C++ classes. So the first is save game. We're going to call this one td main save game. Click create class, it'll do all the stuff it does, and then we'll get back into the editor. So save game slots are one way that Unreal makes saving and loading functionality available. You use it by creating a subclass of save game either in C++, as we'll see here, or in Blueprints. Then you can use some built-in functions to save and load those save game bits of data to a slot. So once the live coding is done, we'll also create another one. This one will be based on game instance. And we'll call this td game instance. The game instance is another built-in class which works a little differently than some of the others. Like game mode and game state, game instance is instantiated when the game is run and sticks around the entire time. Because of this, data saved to it will persist throughout the game's execution, which makes it a good spot to save some information, and I think it makes it a good spot to add functionality for game saving and loading. So with that done, we'll close the editor and get back to Visual Studio. And with the red bar gone, we can hit reload all. So we'll start with our save game. So this is a very simple class. It's effectively just for storing some data. So we're going to add a public. We're going to add a constructor. And we're going to add an int 32 save slot index variable. Anytime you're making a save game subclass in C++, you have to put in UPROPERTY. For this, we're just going to make it visible anywhere. If you leave out this line, you will have problems. It won't save properly. It will not load properly. You'll be very confused. You'll throw in a bunch of logs, printing out the data. The data's all good, but it's not loading. And then you'll make a video about it. So with that done, we're going to create our constructor. And all this is doing is initializing our save slot index to 0, which in C++, it's an int, so it is actually already initialized to 0. With that done, I'm just going to save both of those and close them. For our game instance, there's a bit more. First of all, classes, as you probably know, are private by default. So we're going to add a few variables here. The save slot index and the save slot names, which is just a map of the index to a string. We're putting this in private, so it's only available to game instance, including in Blueprints. But because we want it to be available in Blueprints, we add this part here. Alternatively, you could leave out this and just put it in a protected section instead. Next step, we're going to add a number of functions. So what we have here is we have our constructor. We are overriding init. So if you go to game instance here, you right click and go to definition. You can find init in the public section down here. So here's init. If you hit F12 or go to definition again on that, it'll show you the code. Oops, and then I'll hit a button that I don't mean to. So in init, first thing it's doing is whatever this is. We won't talk about that. It's calling receive init, and then it's doing some other bits of functionality. We'll go back. The reason I'm showing you that is because init is calling receive init, right? And receive init here is a blueprint implementable event. So in Blueprints, if you make a blueprint of a game instance, if you want to initialize, there's no begin play. You need to use receive init. But if you try to find receive init, you won't find it because right here it says the display name in Blueprints will be init. So it is an event. So you just need to find the init event, kind of like a begin play. And you can do your initialization there. We'll go back to our class. We have two functions for loading and saving the actual main save data. Then we have a get save slot. This is being made available to blueprints. However, it's not changing anything, so it is blueprint pure. Set save slot, similarly, is available to blueprints, but is blueprint callable, which means it has exec pins because it's changing the data. And lastly, we just have a convenient, this isn't even being used yet, but get save slot name. So with that in our CPP file, we'll paste this in a little slowly and go piece by piece. So first we're including gameplay statics because that's needed for some loading and saving functions. We need our main save game so that we have access to that class. Just declaring a constant string for the slot name that we're using for the main save. And then in our constructor, I'm just setting the index default to 0 and adding the 3 save slot 1, 2, and 3 slots that we're intending to use. Init's purpose is just to call load main, which we'll get to. We have our utility functions for blueprints. We're just getting the save slot. Again, this is private, so it's not accessible directly. So we have an accessor effectively. And again, the get save slot name is just getting the string based on the index sent. Save slot names is a tmap. If you call find and your key is a string, it will send back the string pointer. I believe it'll be null if it's not found. It'll be the value if it's found, so you can deal with it that way. However, you can also use findRef instead. That will send back an empty string if it's not found. And that is fine for what we are doing. I'll just show this one before the save and load, but set save slot, similar to get save slot, is just taking the index and setting it, and then it's calling the save function directly. For our load and save functions, load main is creating a variable for our main save game, the class that we just created. We are calling load game from slot, and we're sending along the slot name. This is a constant because we want to make sure it's the exact same value down here and here. You could use a string, but then unless you're copy pasting, or even if you are, sometimes things just get messed up, and that can be a pain in the ass bug to track down as well. The result of that is a uSave game, so we need to cast that to our version. We're checking to make sure it's valid. If it is, then we're just setting our local value based on the one in the save slot. In save main, we're doing the opposite. We're creating our main save game variable. We're calling create save game object, and we're setting along the static class of that main game save. And we do still have to cast it to that. If it is not valid, we're printing out a log and returning immediately. If it's good, we're saving the save slot index to the main save game version and then calling save game to slot with that data, the same slot name, and a user index, so we're just leaving it 0. This here was when I was debugging, so we don't actually need the load main called right inside the save main. And with that done, I'm going to compile, and I'll see you back in the editor. And back in the editor, I actually had an issue building. There's a module rules error. I ended up closing Visual Studio, regenerating the project files, and then it was good to go. So I'm not sure what that was about. However, next we want to create a blueprint version of our game instance. So we're going to create a blueprint class. This is based on TD game instance. We'll just call it BP game instance. We're creating this in the blueprints folder, not the main menu folder, because it has to do with the entire game and not just the main menu. Now, unlike game modes, which we make work through the project settings or project settings for map, or in here for a game mode override, the game instance is for the entire execution again. So that needs to go in the project settings, maps and modes, right at the bottom here, game instance class. So we just choose that here. And when we run, it will instantiate the game instance instead of its default game instance. The next up in our function library, I'm going to create another useful get game instance function. All this is doing is calling getGameInstance, the actual version, casting that to our BP game instance. And we'll add a return node here so that I can just drag this on. And we'll get rid of the spaces. And we're going to be using that in our main menus, select save slot. So the first thing we're doing in here is we're going to add the save slot buttons. So we'll throw in a border under the image. Let me undo that. We'll throw in a border under the image. Inside that border, we'll have a vertical box. And the border we want centered. Control Shift. I'm going to make this 400 by 600. And as usual, make this darker. All right, in the vertical box, we want buttons. So we're going to add a button with a text block. The first button will be save slot button, save slot 1 button. That will be a variable. We'll set that to fill. And then we'll just create 2 more with duplicate, Control D. And we can throw in some spacers as well. Just make the spacer an arbitrary 10 by 10. Duplicate this one and drag it down here. And that window is still too big. Let's pop it down a little to 400. And it's a little better. We don't need to make the text variables, and we'll leave them as is. With that done, we're going to go into the graph and create a few variables here. First, we want our buttons in a map. So this will be buttons, type is map. Oh, you have to change this first, I guess, to get the map. Yeah, can't Boolean a map. And in this case, it's going to just be our button. Object reference. We'll have a second one, which is button text, or texts if you prefer. Text controls are text type, so we'll use that. And then we're just going to fill those in our construct. So we call add. Again, this is because you can't just arbitrarily grab them down here in your default section. If we do that, we can't add an element and then try and grab that button. So instead, we're going to manually call add. And it will be for each button. Oops. Zoom in a bit. And that will be for slot 0. I'll just copy paste this a few times for slots 1 and 2. This will be for the other buttons. Oops. Similarly, we want to do the same for button text. So we're going to drag that out, call add. And we'll just call this here save slot 1. Paste it a few more times. This will be slot or index 2, save slot 3, index 1, save slot 2. Incidentally, I've done C++ for a long time. I start indexes at 0. However, these are not actually used as indexes into an array. They're being used for maps and whatnot. So you could have this as 1, 2, and 3 to match the actual text. With that done, we're going to call a new function. We'll call this update button text. We'll get to that in a minute. And we're just calling this at the end of construct, or if you prefer, at the end of construct. And down here we have our back button, and we want 3 new buttons for each of these. And all this is doing is getting our game instance, making sure it's the utility version. And we're using that to call set save slot. The first button is 0, or 1 if you were to use different keys. And then we're calling update button text. So with this, we can duplicate this twice. Just pack these nice and close together. And these indexes just need to be updated. So then in our update button text, we will first get the game instance. We want to get the game slot based on that. So, or save slot. So save slot, and you can see it was a pure function as we set it. And then here we're just going to create a local variable, save slot index. We're doing a for loop, which is way down here. Our index goes from 0 to 2. Again, if you wanted those keys 1, 2, 3, that would be 1 and 3. And we're using this index for both maps, and we're calling find. Oops. So we can check the return values for both of these. We just set it all up. There should be no reason why it's not working. And then we'll use this to save our button text as a local variable. We can call button text. And then we'll use everyone's favorite control, drag out, hit S. So in here, we're taking our save slot index that came from the game instance. We want to compare it to the index that we're iterating through here. And in the case where it is the same, we're going to set our button text based on format text. And that format is just simply the button text, the dash, and current. Not, wow, current. With our button text as this entry here. In either case, on our second sequence here, we're going to take our button. We're going to call getChildAt. So the child of the button is the text block. It's the first index. Buttons can only have one child, so we know what it is. We'll cast this to text block. And with that, we can call set text and send along in our button text. And let's see if that works. So first we need to load our level. We can just double click this to make the main menu our level. It wants to save the stuff first though. And then when we run, we're back in our main menu. We go to select save slot. You can see that the save slot initially was 0, so the first button gets the dash current added to it. If we click on another button, we've saved that value and then called update button text again, which then regenerates all 3 button text, and this one has current. If we go back and then back in, you can see that it is persisting. However, if we stop and then we start, will it work? And it does, because that information has been saved to the main save slot. Thanks for watching. If you liked the video and would like to see more, you know what to do. And if you would like to support this channel, watch these videos 2 weeks early, or just want to download the project files, you can do so through my Patreon linked below.